Hello, grade 9 math class. This is Miss Johnston. Today is Friday, April 1st, and again we have two recordings for today. We're going to be looking at day 3 and day 4. Day 4 and day 5. We'll be skipping over day 3 just because I am away, and hopefully we'll get back to it. All right, so a couple of things we're going to be looking at today are another EQAO question. So if you have a piece of paper, go and grab that now, or any like small area that you can write on for the EQAO question. If you've not completed your Cycle 5 test or task, please do so today. Cycle 6 test will either be Wednesday or Thursday of next week. EQAO will be on Friday of next week and then the following Monday. And our exam for the morning class will be on the following Wednesday, April 13th in the morning, and the afternoon class will be on Thursday, April 14th in the morning as well. And today is a non-uniform day. All right, perfect. Let's get started. All right, so here's your EQAO question. Give it a read. It says, which equation is not a line? Is it A, y equals x squared? B, y equals 3, bracket x plus 2, bracket minus 4, or C, y is equal to 5 divided by 12x minus 5 over 6. If you're the supply teacher, and this would be a good time to pause the video and let students think it out. All right, so let's get to it. So we can, I have the 3 of them that I'm going to show you the graph right here. Hopefully you can see that, yes, the last one looks like our y equals mx plus b form. So yes, this is going to be a line. We can see that here, that it is a straight line. X to the power of 1, just like this one, there's x to the power of 1. Again, b is also a line. So it is in y equals mx plus b form only if we were to expand the 3 out and simplify it, subtracting that constant term by 4. Lastly, we see the y equals x squared term. That is, in fact, a parabola. So that A is not a line. Okay, so we're going to get started. We're going to look at cycle 6, day 4, finding the equation of the line given 2 points on a line. So recall, we have the slope and y-intercept form, most important equation in grade 9 math, y equals mx plus b, where m is the slope and b is the y-intercept. We also can remember that the slope is equal to rise over run. Rise on the y's, and so the rise is on the y's and the run is on our x's. Right, and then we also have the point slope form, which is y minus y1 is equal to mx minus x1, where x1 and y1 are a point and m is a slope. Okay, we're now given a new formula. This new formula is m is equal to y2 minus y1 over x2 minus x1. This is going to help us find the slope of a line. This is actually the change in the y's over the change in the x's, like how many do you rise and how many do you run. We're going to take that and substitute a point into the formula and then write down the equation in both the standard form and the slope y-intercept form. This would be like your standard form, and this would be your slope y-intercept form. All right, so let's go check that out. So we're going to write the equation of the line for the lines shown in the graphs below. Okay, so first of all, we have this line. Can't really see what the y-intercept is, but if we determine the slope, we might be able to check it out, but there is another way of doing that too. Right, so let's go ahead and first of all figure out what the slope is. So our slope is equal to y2 minus y1, so the change in the y's over the change in the x's. So it's really what's the space between your y's and what's the space between your x's. That's all it's asking for. How much do you rise and how much do you run? Right, and we can tell that by just looking at 2 points too. Let's pretend this is point 1 and this is point 2. So we would label this as x1, this one is y1, being point 1, and this one being point 2. So let's say this is x2 and then this is y2. All right, where we see our y2, we're going to put that in for y2. Okay, that means we have a 4 here. Where we see our y1, oh yeah, that's over with the first point. We're going to put that in for y1, leaving the negative being frozen. So The negative doesn't change. Here our y1 is -2, so we're going to put a -2 in for y1. Next, we're going to look for x2. x2 comes first. Okay, that's 3. So we're going to go put a 3 here. And again, our minus is frozen. We can't change that. That's a part of the formula. And then we have a 1 for x1. Okay, so x1 right here is 1. All right, so let's go and figure that out. We have 4 minus -2. And what's a double minus? Double minus gives us that plus. So it's actually 4 plus 2, which is 6. And 3 minus 1, yep, we get 2. Can we reduce that? Absolutely. We get 3 over, do you remember, is it over 0? No, that's undefined, over 1. Okay, so that's our slope. And we're going to use the slope, this formula right here. So we can just put any point in the slope in for here and then make it look like the slope y-intercept form. Yes, you could always do rise over run. Like you could have went 1, 2, 3, 4, 5, 6 and saw it was 6 over 2 and you get it. But eventually you're not going to have any graphs and it's just going to be 2 points. So you're going to have to figure it out algebraically, which is this method. Okay, and then we have this formula. Y subtract y1 is equal to x minus x1. Okay, so we have our first point, x1 and y1. Let's go ahead and put those in here. So our x1 we used as 1, and our y1 we used as -2. So -2 here, 1. Again, that was -2 for our x1, or y1, and 1 for our x1. And we have our slope. We know what our slope is. That's m. We found that. That's 3 over 1, or just 3. There we go. This looks very similar to what we did last unit. So now we have, I'm just going to simplify this a little bit. The two negatives give us a positive, and we can also expand and bring that +2 to the other side. I'm going to bring that +2 to the other side in just a minute after we expand. 3 times x, 3x, and 3 times -1, that's -3. Don't forget to hop that +2 over, and what does it become? Yeah, a -2. So then we have y is equal to 3x. Can we put those two together? Absolutely. -3 and -2, that's -5. There we go. That's the equation of William. That would be a good time to pause the video in case people are still writing things down. I'm just going to keep on going now. All right, for our next one, again, let's pretend like these points aren't on this graph and then that we can't really determine the slope because that's what's going on in our homework. In our homework, we don't have any graph paper, we just have the points, and you have to determine what the equation of the line is. All right, so let's go ahead and check out the steps as we go. So our first step is we're going to find the slope. Using m is equal to y2 minus y1 over x2 minus x1. So go ahead and label your points. X1, y1, and another point, x2, y2. Okay, after you do that, you're going to find the slope. So find the slope using that. We've labeled the points, subpoints into slope. To find m. Number 4, then you're going to use your y minus y1 equals x minus x1 and simplify to get your y equals mx plus b. Right, let's go ahead and try that. It doesn't matter which one you put as x1 and y1. you can put the opposite ones as I do, and then we can check and see if we get the same answer. So go ahead and try that, and I'm going to write down my solutions momentarily. So try it out, use the steps, try it out, and you can see if you got something similar. All right, I put this first one as x1, y1, the second one as x2, y2. And so I have a y2 minus y1 over x2 minus x1. And then I'm going to simplify that, which gives me negative a half. Right? And I'm going to put this into our equation. What is my y1 is 1, negative a half, x, and then a negative 3. So we get y is equal to, bring that over the other side and expand. So I have a negative a half x. This should give me a positive 3 times a half. That gives me negative 3 over 2 plus 1. So y is equal to negative a half x. And then we have negative 1.5 plus 1 gives me negative 0.5. So negative a half. So if you tried it out with the other way, it should be getting the same answer in the end. So I'll highlight where those things came from. Y2, Y1, X2, X1. Here we go. Subbed in the slope into our equation, subbed in X1, Y1 into our equation, and solved. Okay, if you need to pause it at any time, go ahead. All right, and then we have our last example. Write the equation of a line given. Write the equation of the line for the line given the, all right, we have an x-intercept of 2 and a y-intercept of 1. What is the point that has an x-intercept of negative, not positive 2, x-intercept? Remember, the x-intercept is the point that runs along the x. So where is that negative 2? Right here. What is that point? Negative 2, comma 0. What about the y-intercept of 1? So here's our y in the sky. 1 would be right around here. What is that point? That point is 0, comma 1. All right, so that's going to be our 2 points, our 2 coordinates. Let's label this one as x1 and y1, and let's label this one as x2, y2. The ones are just subscripts. They just represent just that one being the first point and that being the second point. But again, it doesn't matter which one's one and which one's two. We'll still get our line that we're looking for right here. All right, so again, step 1, we're going to write down our slope formula. Y2 minus y1 over x2 minus x1. All right, so our y2 is always the change in the y's. The change in the y's over the change in the x's. So is your second point minus your first. Change in the y's, so 1 minus 0 over 0 minus negative 2. And here we get 1 over double negative gives us a positive, so 1 over 2. That's our slope. Then we have our other equation, y minus y1 is equal to mx minus x1. We already know what y1 and x1 are. Y1 was purple, and that was 0. And we're looking for x1. It's right there. It's blue, light blue. Right. That you can't mix and match. You can't go ahead and like pick negative 2 and 1. It has to be from the same point. Okay, so y minus 0 is equal to a half x minus negative 2. So we get y equals, that 0 is gone, because it's minus 0. And the last thing here we have to do is distribute. 1/2 x plus a half times 2, or a half of 2, 1. All right, that's our last equation. You can go ahead and complete the handout for the homework.